And welcome again, everyone, here to today's webinar, where we're going to be talking about building AWS Lambda applications with what we call AWS SAM, or Serverless Application Model.
Again, my name is Chris Munns. I'm a senior developer advocate here with AWS focused on serverless applications. I've been here at AWS approximately 5 years, and I actually come from more of a traditional operations background. Have done much more systems operations than I have application development. But these days, I'm incredibly passionate about the serverless space. So why are we here today? So let's talk very briefly about what serverless means. Serverless is very much kind of an industry hot topic and buzzword today. It means a lot of things to a lot of people. For us here at AWS, basically it means four things when we talk about serverless applications. Now, while the term serverless may not be truthful in the sense that there are servers behind the scenes, you as a user of serverless technologies at AWS do not have to provision or manage any of those servers yourself. Your applications built using some of the technologies we're going to talk about today are meant to scale just directly with their usage, which means you should never have to think about capacity planning or having capacity overhead based on what usage could be, such that you should never have to ever pay for idle infrastructure, which if you were managing servers yourself, even in container-based infrastructure, this is still something you'd have to think about. And then lastly, availability and fault tolerance are built in. So with serverless applications, you should never have to think about things like availability zones. Again, think about things like individual instances. All of that is meant to be handled directly for you. When we come towards talking about what serverless applications look like at AWS, primarily they're based around one product of ours, AWS Lambda. So Lambda is one of the compute services here at AWS. It is, again, our serverless compute service, which is a functions as a service event-driven compute paradigm. Essentially what you have is an event source, and we'll talk about some of those here in a moment, which can be used to trigger and invoke a Lambda function. A Lambda function is going to be code that you have written in one of the four languages that we have listed supporting here, so Node.js, Python, Java, or C#, technically .NET Core. And then this Lambda function can do basically whatever you want it to. So it can interface with other services, it can talk to storage services, it can call other APIs. There's lots of different possibilities for what we see customers doing with serverless applications today. And we bucket these into a number of use cases. So for example, there are customers that are building web applications, application backends, doing data processing, building chatbots, building skills for Amazon Alexa. And lastly, IT automation, which is another popular one. And so Lambda gives you the ability to support all these various different use cases, plus many more. Again, with this a model that there's some sort of event triggering mechanism, and then there is a system on the other side for whatever it is your application might be doing. Now, going back to the slide, and then lastly here where we are is the event sources that trigger AWS Lambda. So in this case, there's a number of different ways you can trigger Lambda. So we have data stores that when records are put into them or objects are stored in them, for example, S3, you could trigger a Lambda function to digest that information, perhaps perform some sort of business logic based on it, do an image resize on images uploaded to S3 as examples. We have a number of deployment and management tools that also allow you to invoke Lambda. So for example, with AWS CloudFormation, you can create a custom resource with Lambda that can allow you to do pretty much anything. With AWS CodeCommit, our hosted code repository service, you could actually have a post-commit trigger that is executing Lambda. And with services like CloudWatch, when you have monitoring alarms that are breached, you can actually have Lambda execute actions on your behalf. In terms of endpoints, we have services such as Amazon API Gateway, the AWS IoT service, AWS Step Functions, all of which provide a methodology for you to trigger functions based on certain actions. In the case of an API gateway, this could be used to power a microservices environment, a mobile application, a web-based application, and allows you to build a completely serverless backend for those without you having to manage any infrastructure whatsoever. Then we also have a number of event messaging services such as Amazon SNS, Amazon SES, which you can also use to invoke Lambda based on certain conditions. And lastly, you could also do things like prod events, which we'll talk a little bit here today. So given that we have all these different methodologies for invoking Lambda functions, there's a number of different characteristics for how you could configure a Lambda function, and then there's going to be a lot of potential resources that could be on the other side of that Lambda function that you're interfacing with, that you're calling, that you're working with. it presents us with a number of challenges towards how we go about managing, provisioning, updating, and being able to potentially recreate those resources in other accounts, other regions, and so forth. And so in order to help with this, we're going to be spending most of our time today talking about SAM. So you'll see a number of these squirrel images here. Sam the squirrel is the mascot for AWS Lambda and AWS Serverless applications. You'll be seeing Sam in a lot more of our presentations and on web pages and stuff. And if you get a chance to make it out to any AWS events that are local in your area, be sure to look for the SAM stickers and t-shirts and other goodies that we'll be handing out. So what is SAM? So SAM actually stands for Serverless Application Model. And this is something that we launched back towards the end of 2016, November 2016. So SAM is a CloudFormation extension that is optimized for serverless. So it's essentially built on top of AWS CloudFormation, which is a service that we have here at AWS that's been around for a number of years now. And what it does as an extension of it is it greatly simplifies the work that you need to do in order for you to manage certain resources. In this case, we have 3 AWS resources specific to serverless that are in SAM. You have functions, APIs, and tables. And we're going to be talking about all of this a lot more here today. SAM, though, being just an extension on top of CloudFormation, means that it also supports pretty much everything that CloudFormation supports itself. And we'll talk about some of the gotchas here later. And then lastly, we actually open source the specification for this. So the URL that you see here on the bottom of the screen, which is github.com/AWS/serverless-application model, is where you can go to find, again, publicly in GitHub, the documentation for the specification, examples, all sorts of information about it. And we are continuing to update this as well as merge in people's requests or pull requests that they have for better documentation and so forth. So, feel free to check it out. It's the best place to find all of the information about SAM. And actually, most of what I'm going to be talking about today could be found in that repository. So I want to hone in here on one aspect of this, which is that SAM is an extension for CloudFormation. And some of you may not be familiar with CloudFormation, so let's talk about it here briefly. So CloudFormation is, again, a service here at AWS that's been around for a number of years that allows you to create templates that represent your infrastructure. So you can create these documents that can be either JSON or YAML today. And what happens is you pass this document into CloudFormation, and then it goes and provisions those AWS resources for you. It takes care of things such as dependency needs. So, for example, if you're creating an EC2 instance and it has a security group and EBS volume, it knows the order of operations for creating those without you having to dictate or order them yourselves. So they don't have to be so specific in the documents. And then some of the pluses here to CloudFormation is that you can version control these documents. You can easily share them with teammates across your organization or even publicly. And then it allows you to take these templates and update them against the service just like you would application code. So you can track, link, and even test the changes to make sure that they are valid if they meet certain demands. And then lastly, you can take this tool, CloudFormation, because it is a code-based service, and treat it just like your application code. So you can have it as part of a continuous integration or continuous delivery process. You can integrate it with other management tools. And so there's a whole number of capabilities. And we actually have many other webinars and presentations about CloudFormation. And so we're not going to go too in-depth on all of its capabilities today. So I definitely encourage you to take a look at those if you get a chance. Now, if we were to look at what would be involved in having a CloudFormation template that can launch a serverless application, it would look a little something like this. Now, I wouldn't expect you to read all of this content. Probably a little bit too verbose for what you're going to need. And so basically what SAM does is aim to make it such that you don't have to think about all of these lines of code. In fact, if we were to take this 80 or so lines of code that exist here and convert it into a SAM template, it looks a little like this. So this is about 20 lines of code, max I guess here, that represents those other 80 lines of code. So let's look a little bit more about what's going on here in the sample. So at the top here we have basically what's considered the header in CloudFormation. So we have a template format version, and then we have the transform line. And now the transform line is what's key here about SAM. Basically what this tells CloudFormation when it goes to execute our SAM template is that this is a transformation template, so basically an extension onto the service, and so that it should understand that there are certain resources here that will need to match against that transform. And so if you're going to build a SAM template, these first two lines are incredibly crucial to the ability for this template to be understood by the CloudFormation service. Then down below here, what we have is two resources. One is called getHTML function, and the other is called list table. Now, the first one is of the type AWS Serverless function. So this is a function representation for Lambda. And we can see various properties about it, where its code is stored, where the handler points to, the runtime, basically the role policy that we want to assign for this. And then we go down to events here. What it actually shows us is the mapping of the event that we want to have that will trigger this function. So if you look down here at type, where we see API, this is actually going to create for us an API gateway and map it back to our Lambda function with the path and the method and other properties set as defined here. And so in this case, this one resource definition is going to create the Lambda function represented by our code URI and the handler and runtime, the policies. So I'm going to create the API gateway because this has an event type of API. It's going to handle all of the IAM permissioning for allowing this function to exist and to run and to be called by API gateway. And it's going to deploy our function for us, all with just kind of really the 10 or 11 or 12 lines of code that you see here as part of this. Then down towards the bottom here, the list table has a type of serverless simple table. This is going to create a very basic DynamoDB table for us with a base 5 read and write units. And if you know anything about DynamoDB, basically the read and write units are effectively how you think about scaling DynamoDB. So just by declaring this resource as it is, it's going to give us a DynamoDB table with 5 read or write units per second, basically. That is pretty good for getting started with most functions. So another way to visualize this is a screenshot from another code repository that we have, for an example that we have up in GitHub called AWS Serverless SAM Farm. And what we see here from this one template, basically lines 9 through 25, is that this one resource, which is called getSamPartyCount, goes on and creates a number of actual resources inside of your AWS account. So it's going to create the Lambda function, it's going to create a role, it's going to create an API gateway, and then a stage for it. Then going to create permissions for both of these resources, and then it would go and deploy your code for you. So again, just these couple of lines of code generate all these other resources without you having to put together all of the pieces yourself. So this is a great simplification of the work that's involved in managing serverless applications. So again, with SAM templates, they allow you to mix in non-SAM CloudFormation components inside of the SAM template. So SAM itself only declares 3 special functions, or 3 special resource definitions, I should say, function, API, and then simple table. But you can still mix in other resources yourself. For example, creating an S3 bucket, a Kinesis stream, defining step functions, execution flow. Pretty much anything else that's an AWS CloudFormation resource could be mixed into your SAM template. And CloudFormation is smart enough to know that with the transform header being set, they'll look at transforming the resources that are defined as part of that transformation's identification. Supports the ability for you to use things such as parameters, mappings, and outputs inside of your template. These are very much key foundational components of CloudFormation itself. Parameters are essentially values that are passed in at execution time. And we'll talk a little bit more about how that can be done as part of an automated process here later. But effectively, these are dynamic inputs that you, as a user of this template, can pass in to allow you to customize or add dynamicness to all sorts of different aspects about this CloudFormation template. We have mappings, which are predefined. You can think of them as key value mappings inside of the document. So for example, you could say that based on a certain parameter being set, that might impact potentially the timeout or the amount of memory for a Lambda function. And so these mappings, again, are hard-coded into the template, but give you another level of dynamicness. And then lastly, outputs give you the ability to take the output reference variables from the resources that are created by the SAM template and pull those back into other applications or potentially consume them by other templates, whether they be CloudFormation templates or SAM templates. And so this is a great way for you to pass information from one essentially CloudFormation stack to another without you having to do some sort of kind of programmatic lookup in the middle. They also support intrinsic functions. We have a number of different capabilities inside of CloudFormation that allow you to reference parameters, to be able to merge together various components of strings, to split strings, to do a whole number of different things that are part of CloudFormation. You can use import value, so going back again to the ability for you to take outputs from one template and pass them into another. Import value is a great way for you to consume other attributes or other resources from inside of your infrastructure, again, without having to maybe pass them in as parameters or have them hard-coded as mappings, or have them hard-coded inside of the actual template itself. And so import value is a key part of the dynamicness inside of CloudFormation and SAM templates. And SAM, because it is built on top of CloudFormation, also supports YAML or JSON. And so totally up to you to pick which one you want to use for those, for your templates, but either is supported. And again, really aren't going to go too in depth of all the capabilities of CloudFormation today, but would encourage you to take a look at the CloudFormation documentation to find out a little bit more. So let's talk a little bit about SAM templates themselves and the properties of the resources that exist inside of SAM as an extension on top of CloudFormation. And again, there's 3 of these today: function, API, and simple table. And so we'll go through kind of the capabilities of all of these. And again, this is from the current SAM version, which has a version identifier of 2016-10-31. As you can imagine, we launched this last year right around Halloween here in the United States. And so as we continue to add more capabilities to SAM, we currently haven't had any need to bump the version or to change it over time. We're just doing additive changes. But keep an eye in the future on if there is a reason for us to change this and how it might impact your SAM templates. So let's dive into a function here. So basically, these are all the capabilities that we have inside of a function as defined in a SAM template. So the handler, the runtime, where the code can live, our description of this function, memory size, timeout, the policies, and we can actually have an extended policy document inside of this based on the IAM policy syntax. We then can also specify environment variables, which we'll talk a little bit here about later today, events, which we're going to talk about more events here in a moment, and then lastly tags, which was a recent addition to Lambda, the ability to tag your functions, tags being a really important way for you to identify resources in your AWS account for things such as billing purposes, permissioning purposes, resource grouping. There's a lot of different benefits to tags. And so again here, basically what's exposed here is more or less every configurable option for a Lambda function you would ever need. Hopefully in giving you kind of the full capabilities that you would see in the normal CloudFormation Lambda function resource, but slightly simplified. If we go now and look at the next resource to talk about here, Serverless API. Serverless API actually streamlines things quite a bit here. So in this case, for Serverless API, we have the ability to create a stage. That stage can then have a definition URI, which could be a Swagger file, which is included inside of a code repository, or actually could also be inline to the template. So you can include a Swagger definition inside of this template file. Whether you want to have cache cluster enabled or not, if you do, what size you want, and there are a number of different predefined sizes for cache clusters. This is for API Gateway's ability to do query caching locally in itself. And then lastly, variables, which again we'll be talking about variables for both functions and API stages here a little shortly. And then lastly, simple table again, which is going to provision for you a DynamoDB table. This is going to create, again, all you need to do is declare the resource itself, but there are a number of different characteristics that you can configure about it. So you can define the primary key and its type, and then you can also predefine the provision throughput that you want to start with. Again, it starts with a base of 5 read and 5 write capacity units. So looking at the 3 of these, there's not a whole lot that you would need to configure across these capabilities. And again, what happens behind the scenes is SAM is interpreted by CloudFormation, and it goes and it understands what you defined as well as what you haven't defined that it's going to have to figure out for you, such as IAM permissioning, to make sure that the resources that you define have the ability to communicate or invoke each other or operate in general. Now let's talk a little bit about the event sources. So again, a serverless application is typically made up of an event source, a Lambda function, and then some sort of action behind the scenes. We've already talked a little bit here about what the API resource looks like. And so that is typically defined as an event, but we'll talk about some of the other event source types that are pretty popular. And there's a couple of things to understand about how an event source is organized and defined inside of a SAM template. So first we see that event source objects have the following structure, essentially a type and then properties. And then based obviously on the event source, there'll be various different properties. As we can see here in this example, I have events and then I have an event name. So technically an event source is a map inside of the string that is named however you declare it. You can have multiple events trigger a Lambda function. So I could have events that say my photo upload, my scheduled events, my CloudWatch events, and have those various types as individual events that are named as such here. Let's dive in here. So inside of S3, we have the ability to basically define the bucket that is going to be the source for where these events are going to come from. One gotcha that you do have to be aware of today is that the S3 buckets must be declared inside of the same template. So one thing that we do not support today inside of SAM is the ability for you to use a pre-existing bucket. Now, part of this is because when our SAM template goes to get transformed and executed inside of CloudFormation, is that it's going to apply the appropriate permissioning controls across both S3 and Lambda for us, such that we have the ability to get objects out of this bucket without there being any sort of concerns about the permission controls. And so you do have to basically declare the S3 bucket inside of this. Now, you don't have to necessarily create it as an individual resource. If you do have it listed here as an event, we will create it for you. Or you could specify the bucket with whatever policies or other controls that you want inside of the same template. Next up are events. There's a number of S3 supported events that you can read about online. These are things such as objects being put into a bucket, being modified, new versions, being deleted. There's all sorts of different events that will be able to trigger a Lambda invocation. And then you have the ability to filter these. So as we look down further here in the properties, we see filter based on S3 key, and then the rules. And you can have a number of these rules based on either the prefix or the suffix of the key itself. And so this could be things such as any time that a .jpeg gets dropped into an S3 bucket, I want to execute maybe a metadata grab about that object, or I want to generate a thumbnail about it or resize it. Or something based off of the prefix, potentially if I'm looking for records that contain some sort of a certain name up front. And so lots of different capabilities of this, and again, quite a lot of flexibility inside of both the events supported as well as the rules that you can use for filtering. Next up we have SNS, so pretty straightforward here. Basically you just define the topic, and this can be a pre-existing topic that exists somewhere else in your infrastructure, whether it be created outside of the SAM templates or inside of the template. So pretty straightforward. Specify the topic name, and what this means is that as messages come in across SNS, it will invoke Lambda, and this is going to help with the permissioning on the Lambda side. Kinesis and DynamoDB streams both look pretty much exactly the same, with the difference being the way that the ARN is structured for the stream. So an ARN is basically an Amazon resource identification string. And so we see here between Kinesis and DynamoDB that we have three properties: stream, starting position, and then batch size. And again, the stream is going to look a little different depending on which one of these is. And then the starting position either set for trim, horizon, or latest. So it's important to know the differences between how those two work. Trim horizon will go all the way as far back as the length of durability, or the length of basically storage of the stream. And the latest is going to pull off just the latest items as they come across the stream in order for Lambda to be invoked. Batch size then is totally dependent on you, and it becomes more of an issue in terms of what the work is that you're doing inside of Lambda. So if you have a really huge batch size, it could be that your Lambda function is taking on too many records, and it could end up resulting in a Lambda timeout. Or you could find that if you're taking on too few records, it could take you a really long time for you to digest all of the data from your stream. And so batch size is very much an important aspect in terms of the overall performance of your ability to process data from Kinesis or from DynamoDB. Schedule, this is a real fun one here. So with Lambda today, and technically behind the scenes CloudWatch events, we give you the ability to schedule Lambda functions. So here we see type schedule. Underneath the properties, there is a schedule and then potentially an input, which is a JSON formatted string. So even if you are using the YAML format for your template, the input still has to be structured as JSON. That's an important thing to be aware of here. Regardless of what you write your template in, that input must still be JSON, as that is what the underlying service itself is able to understand, in this case, what Lambda is going to consume. So we see different examples, two examples here. One is of a cron expression. The other is of a rate expression. Rate expression is really straightforward. You have either a singular or a pluralized time set. So you see here 10 minutes or 1 hour. You could have a day, number of other different rates that exist that you find in the documentation. And then cron is very similar to traditional Linux-based cron. In this case, there are 6 attributes to it. And so you see here an example of every minute I want to run a Lambda function, or the second example, which is every 5 minutes between 8 a.m. and 5 p.m., Monday to Friday, I want to execute this one Lambda function. So lots of cool things that you could do here with this in terms of, say, replacing infrastructure that you have today that could more or less just be running cron. You could actually pass this off to Lambda, greatly simplify the process. CloudWatch events, another type that we have that is pretty popular. Today there are over 14 different CloudWatch event types that exist, many of them with several different actions inside of them. So for example, EC2 events is a type of event. As part of that, there is, I believe, well over a dozen or individual events that are part of that event type, such as an instance coming down, an instance being terminated, an instance being put in stop mode, an instance starting. And basically what you can do as part of this is that anytime a CloudWatch event captures an event that matches the pattern, you have the ability then to execute a Lambda function. So this can be really great for incident response. This can be really great as part of just raw IT or infrastructure automation. And so there's lots of different use cases for this across a number of different other AWS services that have the ability to trigger CloudWatch events. So what we see here is that you might want to input basically JSON that overrides some of the context of the matched event. And you have the ability to insert where that is going to be inside of the JSON structure that CloudWatch events itself captures from the service that invoked the CloudWatch event, or basically that it captured, which is now going to invoke the Lambda function. And then lastly here we have Alexa skills. And so for those of you who may or may not be familiar with Alexa, Alexa is the automated bot that basically lives inside a number of devices from Amazon, such as the Echo, the Dot, the Tap, and the Fire TV. The way that Alexa works is that it has what are called skills, which are these, you can think of them as kind of individual capabilities inside of Alexa that allows it to perform actions. So as an example of this, I more or less every day in my apartment say, Alexa, what will the weather be today? And so Alexa then executes the weather skill, which goes to its backend and looks up the weather and tells it back to me. In this case, one of the best ways to host Alexa skills is inside of Lambda. And so in this case with SAM, you can deploy the backend for your Alexa skill just by defining the type. And now in this case, there aren't any properties to Alexa skill, but what this is going to do once you've defined this type for the event is it's going to create a resource policy that allows the Amazon Alexa service to invoke your Lambda function. So thereby greatly helping to simplify the permissioning there. One cool thing to note right now is that we are actually currently doing something for developers of Alexa skills, by which we will help give you $100 in AWS credits every month for your Alexa skill. And so be sure to check out the Alexa developers blog to find out more about that. There's a lot of really cool and interesting stuff going on in this space. And Lambda makes a really great backend for Alexa. So I'm going to change gears here a little bit. So we've talked a little bit about the overall properties of our template. We've talked about, the overall resources of the template. Then we talked about the Lambda event triggering types. Then I'm talking about some of the more kind of nuanced capabilities that exist inside of some of these services. So inside of Lambda, as part of it, we have the concept of environment variables. Much like as the name sounds, these are a key value pair of information that you can pass into your function. And so this can be useful for all sorts of things. This could be useful for passing in things such as feature flags. It can be useful for passing in information such as database credentials or other API credentials, a number of different reasons that you might want to pass in configuration information to your function. And now these variables are made available directly to the runtime environment of your Lambda function, such they can be picked up just as any other like OS level type of environment variable could be. So for example, using process.environment in Node.js or os.environment for Python, and the equivalents exist for Java and for C# as well. You also have the ability to encrypt these, which gives you the ability to basically make these objects or these key value pairs a little more secretive, although we do have to say that currently this is not supported in SAM, but it is one of the overall benefits of Lambda. API Gateway has similar capabilities, so it has what are called stage variables. They are essentially very much the equivalent to environment variables, except that they can live at the stage level. So a stage is, you can think of it as kind of a environmental defining point, if you will, inside of an API gateway, such that you can have stages such as, beta, prod, staging, development, etc. And then these stage variables act as environment variables at that stage level. They are then accessible inside of the requests that go back to the backend, for example. So you can use these to pass in based on what stage is receiving the request, other information to the backend such that it can be treated as an environment variable for those as well. And so inside of SAM today, we make it pretty easy for you to pass in these variables, both environment variables in Lambda and stage variables inside of API Gateway. And so we see here an example where I have two parameters inside of my SAM template. And again, parameters are the ability for at execution time of the template you to pass in dynamic information. So we see here that I have a parameter called my environment. I also have a parameter called special feature 1. You may this as a feature flag. And so for my environment, it is of type string. I have a default called testing, and then I have 3 values that I allow: testing, staging, and prod. And this is a description of what the environment is for this stack of resources. And then special feature 1 is a string. Basically, you can think of it almost as just kind of a string-based binary of true or false, and this would be to maybe enable some capability of my application. And so then you see here how in both the Lambda function and the API Gateway stage resource definition on the right-hand side that I'm using the intrinsic function called ref, which is defined by that exclamation and then ref, to consume those parameters into the resource for my Lambda function and for my stage. And then again, that code, those environment variables will be made available to the Lambda function, as well as be available inside of the content of the API request that comes back to my Lambda function via an API gateway. And so either of these could be good ways, again, to add that extra bit of dynamicness, again, for things such as defining different characteristics inside of the same Lambda code, and also, again, making these templates that much more reusable for various different environment stages inside of your application. So let's talk about just a couple of SAM best practices here. So, when you're working with SAM, again, there's a couple of things that you want to think about, and in terms of especially how you structure your files inside of Lambda. Sometimes people talk about having many Lambda functions inside of a single repository. Some talk about breaking it down very far. Typically, what I like to recommend is that if the function handlers share code, then it makes sense to keep them inside of a single file. If they don't share code, however, you probably want to split them into their own individual function files or binaries if you're using Java or C#. And then another option for shared code is to use language-specific packages, such as NPM or pip packages for Node.js or for Python, respectively. Then, based off of that, unless the independent Lambda functions share event sources, split them into their own code repositories with their own SAM templates. And so what this means is when you think about how you draw essentially the border around what becomes a serverless application, if the code doesn't share any common other code aspects, but does maybe share things such as other infrastructure resources, keep them inside of the same repository, have them be potentially managed by the same SAM template. However, if they don't share code and they don't share event resources, you actually want to think about those as maybe their own individual nano stacks, if you will, in terms of how small they might be contained. And so in this case, you might just have a single event source, and even as little as a single Lambda function definition being its own repository with its own code, with its own SAM template. And then because these SAM templates share characteristics of CloudFormation, you have the ability to lint these using traditional open source tools for linting YAML or JSON files. These exist in almost every programming language today, so Node.js, Python, various command line based tools, as well as various web-based tools and IDE-based tools that exist today. And so typically you're going to want to do this before you commit it up to the CloudFormation service. One thing that can happen is if your template isn't valid, that will cause the CloudFormation service to return to you an error pretty quickly, but again, you'd always like to catch those. And then if you do have a formalized continuous integration and continuous delivery process, it makes sense for there to be a step inside of that, which is to lint the template itself before you pass it up to the service. So catch it in both places just to make sure that you aren't missing anything. Another is to understand that SAM templates and CloudFormation templates in general are meant to make it so that it's very, very easy for you to manage multiple environments. For example, talking about how parameters and mappings add dynamicness to your template, you should be able to use a single SAM template to represent dev, testing, and prod, or however you define your environments inside of your infrastructure. You really shouldn't have to have separate ones as part of that. Based on your ability to consume, again, parameters, mappings, and the references from those, as well as being able to consume input values from other stacks, it should allow you to basically make these templates highly reusable. And you really want to aim for that, and if you find that you do have to create different templates per environment, you might want to think a little bit more about the actual structure that you're using there. And again, then lastly, use the same template to repeat your process of snapping out new environments, and this could exist inside of the same account, across different accounts, across different regions. CloudFormation and therefore SAM provide a number of mechanisms to help make this easy for you. So after you have your template and you have your repo and you have everything else set up and ready to go, what do you do then? Well, what we've done with CloudFormation is extended it with two commands, package and then deploy. What package is going to do is it's going to create a deployment package based on the application that you're deploying and the language type. Then going to take that and create a zip file and toss it up into S3 for you. And then what this does is it passes back the ability for you to have a dynamic code URI based on the S3 URI where the object has been uploaded. So if you saw in some of my examples for Lambda function definitions previously, I did have a hard-coded URI specified there, but you could actually make this dynamic as part of your CI and CD process. And then you can call the deploy command. So what happens with the deploy command is that it actually is running two different CloudFormation commands under the hood. One is to create a change set, which is basically a function inside of CloudFormation that allows you to see the difference between a existing template or a brand new template, basically a dry run of what will happen. And then the second is to then execute that change set, effectively apply the changes or apply the new resource creation to either an existing stack or a new stack. And so these two new commands are essentially what you need to do in order to take that SAM template in all of your code and all of your resources inside of your repository and upload those to S3, deploy them then to Lambda, and invoke the creation of all of the resources that are defined inside of your SAM template. There's a couple different ways to do this. One is you have the ability to use AWS CodeBuild, which is a fully managed build service that we have. CodeBuild can be used for doing things such as doing unit tests of your application code, linting of your application code, as well as kind of some functional testing of it. And so CodeBuild is a pay-by-the-minute service that is completely managed. You never have to think about running any servers yourself, and has integration with tools such as CodePipeline and Jenkins. CodeBuild looks for a configuration file, which can either be hard-coded into the service itself or could exist as a text file inside of your code repository. This is called a buildspec.yml file. And so we see here the structure that exists for this file. So very similar to a SAM a template definition in terms of, in this case, it's a YAML-based file. It has a couple of different predefined sections to it. So we have environment variables that allow you to, much like environment variables inside of Lambda functions, specify low-level operating system environment variables that can be processed by the commands that will run in the second block here, which is the phases block. There are 4 phases to a code build execution: install, pre-build, build, and post-build. And inside of these, basically, you're executing shell commands. So we're seeing here that I have this, this build spec file for a Node.js project. I'm doing npm install to install the package dependencies that my Lambda function has. I'm running a tool called ESLint, which is a linting tool for JavaScript against all the JavaScript files inside of my repository. I'm then going to execute npm test to potentially execute unit tests from my code. And then lastly, I'm calling the AWS CloudFormation package command, which will create the basically the SAM template based off of the packaged up version of my application code, which has been put in S3. And then we see down below here, in terms of the artifacts, it is going to take my post.saml.yml file and my beta.json, zip those up, and put those up into S3 as well. And so this is using this, again, with CodeBuild. Now, you don't have to call CloudFormation package or deploy from inside of CodeBuild, but this is one really pretty easy way to get started with all of this. The next thing I'll talk about is how you can go about basically automating both the building of your code as well as the deployment across various stages. And so we consider this a typical, fairly standard continuous delivery workflow for us, or a pipeline. And so for this, AWS has another service called AWS CodePipeline. With CodePipeline, it allows you to model out your application's lifecycle and its delivery flow, such that you can have build capabilities, test capabilities, and deploys across various stages anytime that code is changed. And so today it plugs into a number of different source control services, such as GitHub and CodeCommit. Also plugs into build services, such as CodeBuild, which I just showed, as well as Jenkins and some others. Then also plugs into a number of deploy capabilities. In this case, we'll be focusing on CloudFormation deploy capability, but it also plugs into services such as AWS Code Deploy and AWS Elastic Beanstalk, as well as providing kind of an open-ended integration system such that you could call out to Lambda functions, actually, or call out to other third-party partners that we have. And so this is kind of an example of what a pipeline flow might look like for a SAM template that I'm looking to deploy. In this case, I'm going to commit my code to my source repository, then going to package and test my application inside of CodeBuild, and then I will use CloudFormation actions inside of CodePipeline to create or update my stack via the SAM template that lives inside of that code repository. So basically what will happen here is the action will look for the SAM template and look to execute it inside of my actual code repository artifact. I have the ability then to make use of specific stage or environment variable parameter files to pass into Lambda or into API Gateway. And then I have the ability to invoke tests. So for example, I could call an API testing service to test my API service. There are services out there for testing things like chatbots, lots of different things that I could plug into my code pipeline to make sure that my application meets the standards that I've set. Here's a very basic example, again, of this existing. And again, CodePipeline is a very visual service, so you see visually the workflow that exists. So you see here, this is what is called a 3-stage pipeline. We have our source stage, then I have a build stage, which builds my code artifact. Then I have a single, what I call, development stage, which is going to deploy my code up to what I'm considering my development environment, first creating a change set, then executing it. And then I'm going to call Lambda actually to do some testing. In this case, I'm going to stub out the functionality of my Lambda function to make sure that it performs the way that it should. And there's a number of open source test tools as well as traditional language-based test tools that help make this really easy for you. In terms of passing in parameters, there's actually 2 really awesome ways that you can do this inside of CodePipeline with CloudFormation. So one is that you can reference a file that will also, or could potentially also live inside of your code repository. And so some benefits and cons to that, which I'll talk about here in a moment. The other is that you can actually specify in the pipeline an actual JSON structure here, which shows the parameters that I'd want to pass in. Again, these parameters being something that will be consumed by the template at execution time. So by referencing a parameter file. This allows the developers to control and update this inside of the code repository. You can make it much easier to change and iterate this as part of a deployment. One concern with this is that if you are passing in things such as database credentials or API tokens or something that might have potentially confidentiality or security controls around it, is that because you are putting this in a clear text file that then potentially gets stored inside of a revision control system, you do have to think about how that is accessed and controlled. If we look at the parameter overrides, this allows you to control this a little bit better inside of the execution of the pipeline itself. So you can basically control who has access to view these parameter overrides as part of IAM permissioning for your pipeline. So it could be a little bit better for secret information. The cons to this is that it requires you to edit the pipeline in order for you to change these values, which would require you to then re-execute an entire pipeline flow in order for them to take effect. And so then lastly, it's a little harder to track these changes inside of CodePipeline. For example, if someone changes one value to another, unless you're actually controlling your pipeline, say, via CloudFormation, which is an option as part of CloudFormation. So again, two different ways for handling this inside of CodePipeline for passing in those parameters that add more dynamicness to your template. So here is kind of an extended version of that pipeline example. This is one we could say is maybe a minimal production pipeline. In this case, I have 5 stages. I have my source stage. I have a single build stage, which is going to build my code artifact for my application. I then have 3 what I call deployed environments. So I have a testing, staging, and a prod. In this case, I'm using change sets, create, and execute as actions inside of each of these. And then I have a number of other actions. So I have an action called run stubs again to test my Lambda function. I can call out to run scope, which is a third-party API testing service. You also see here in the deploy staging stage that I have a manual approval that maybe I allow my QA team to do a sign-off on. And then lastly, once I deploy inside of my deployment stage to prod, I have the ability to say call a Lambda function that is going to put a notification in a Slack channel to say that a deploy happened. So lots of different capabilities, lots of different possibilities for how you can cut this. Really the key thing to highlight here is that there's a lot of benefits to thinking about a formal and structured CI and CD pipeline process for your serverless applications. SAM makes it really easy to be incredibly dynamic about how it handles the properties and potentially mappings inside of your SAM document, such that it's very easy for you to have testing, staging, and prod all defined inside of a single repository, inside of a single template, without you having to do anything specific for these various environments. So kind of rounding it up here, I know we're running a little short on time due to some of the technical issues. A couple weeks back, or actually back in April, we launched a product here at AWS called AWS CodeStar. AWS CodeStar is an interface that sits across a number of other AWS services, such that it will automatically provision for you a code repository, a pipeline, a build action, and then a deploy action across a number of predefined what we call project types. So there are a couple different project types for serverless applications for a number of our languages, where again it's going to glue together all those components for you and glue together all of the permissioning and capabilities. And I'm going to come back to here in a demo here, I think, in a moment, if I have enough time. The other thing I want to mention real quick here is we have a landing page for serverless we launched a couple of months ago. Probably the best place to find all the various resources that exist around serverless computing at AWS. You can find us at aws.amazon.com/serverless. And then lastly, just some other links to resources here from this talk today. So you can find, again, the specification for SAM, Serverless Application Model, up at github.com under the AWS Labs organization inside of Serverless Application Model. Has all the content that I shared today about Serverless Application Model, the resource types that we have, the event types that we have, as well as a number of examples for each of those. So definitely encourage you to take a look at it. You can obviously find out more about Lambda and API Gateway by going to aws.amazon.com/lambda or /API-gateway. And then we talked a little bit today about CloudFormation, CodePipeline, and CodeBuild. And it looks like I managed to somehow butcher the CodeBuild URL. It should be amazon.com/CodeBuild. But again, lots of documentation, lots of examples, and links to presentations such as this one today. I'm going to try to switch over here to, I think, Q&A, actually. My apologies for not being able to do a demo. I think what we'll attempt to do for the recording here is to cut to a demo after Q&A. So if you come back and check out the recording when we post it here in a couple of days, you will see a demo of CodeStar, or you could head to the CodeStar landing page and see more or less what I was going to show. But I want to take a break here and go to the Q&A and try to answer some of the questions that might be outstanding. Real quick, though, I do want to thank you very much for joining us here today. Apologize deeply for the technical issues earlier, and appreciate all of you who stuck by with us for this, and hope to see you soon in a future webinar. So thank you again.